जुन ज्योमेट्रीको आइसोमरमा सिस टर्न्स जेड एन्ड द ई याद गर्नुपर्ने र त्यसको लागि चाहिँ नि हामीले एक्जाम्पल डिफ्रेन्ट एक्जाम्पल र मोडल दिएर चाहिँ नि सिस टु ब्युटिन र म्यालिक फिमेरिक एसिड दिएर हामीले एक्सप्लेन गर्यो भन्दाखेरि सो ज्योमेट्रिकल आइसोमरिजम भन्ने बित्तिकै सिस टर्न्स जेड एन्ड ई लाई याद गर्नु होला नाउ लेट्स कम टु द अप्टिकल आइसोमरिजम यो सुरु भएको छैन है
Ma'am, bachayna.
Okay, so in the case of optical isomerism, isomerism the stereoisomerism, geometrical isomerism we have finished, and we are doing the optical isomerism. And in the case of optical isomerism, optical, it is related with the optical activity. Okay, it is related with the optical activity. Optical activity optical activity it is related to the plane polarized light. Okay, optical activity within it is related to plane polarized light. Our plane polarized light the light waves that vibrate in only one plane is known as the plane polarized light. If it vibrates in all the direction, that is not the plane polarized light. It is an ordinary light. But we can change the ordinary light into plane polarized light by passing through the nickel prism. If an ordinary light is passed through the nickel prism, we get the light that vibrates in only one plane. Okay, and how it is related to optical activity is that if any organic compound, it rotates the plane polarized light, okay, plane polarized light, then that is known as optically active compound. Plane polarized light, just a practical you plane polarized light ko source huncha, okay, yeah, we can put the sample, any organic sample. Organic sample like maybe lemon juice, orange juice, whatever the organic compound plain polarized light pass garincha, and if it's viewed from this side, if the plane polarized light has not deflected at all, plane polarized light without any deflection, organic compound is said to be optically inactive. The optical isomerism like it should be optically active. Optically active by passing the plane polarized light to the sample. Sample ma pass garदाखेरि यदि त्यो plane polarized light as it is यस्तै छ no deflection यताबाट हेर्दाखेरि भन्दाखेरि it is optically inactive. तर if the plane polarized light is passed through an organic solution and if it has deflected like this, पहिला plane polarized यताको जुन पढाएको छ भन्दाखेरि पछि यसरी deflection भइरहेको छ भने now that is optically active. त्यो deflection यसरी पनि हुन सक्छ अथवा यताबाट पनि हुन सक्छ भन्दाखेरि त्यो जुन plane polarized light may rotate to clockwise direction or it may rotate to anti-clockwise direction. Right? And that type of the optical compound, organic compound is said to be optically active compound. So the organic compound which rotates the plane polarized light is known as optically active compound. The compound which rotates the plane polarized light to clockwise direction, okay, right hand side is known as the dextrorotatory, symbolized by small d or the positive sign, not the capital D, small d, and its isomer which rotates the plane polarized light to anti-clockwise direction to the same extent is known as the levorotatory, that is symbolized by small l or the negative sign. The isomers which rotate the plane polarized light is known as optical isomer. So what is optical isomer? So the stereoisomer which rotates the plane polarized light is known as optical isomer, and the phenomenon is known as optical isomerism. The optical isomer which rotates the plane polarized light to clockwise direction is known as dextrorotatory, and its isomer is which rotates the plane polarized light to anti-clockwise direction to the same extent is known as the levorotatory. So what is optical isomerism? Optical isomerism is related with the optical activity. Optical activity भन्दाखेरि के हो त? के भयो भने organic compounds मा के property भयो भन्दाखेरि के गर्यो भने त्यसलाई optically active compound भन्छ भन्दाखेरि plane polarized light लाई deflection गर्नु पर्यो. Okay, optically active compound. It should rotate the plane polarized light. So now we are talking about the stereoisomerism, and stereoisomerism हामीले के छ optical isomers परिरहेछ भन्दाखेरि, so what is optical isomers भन्दाखेरि, it is one type of the stereoisomer, okay, the stereoisomer which rotates the plane polarized light is known as the optical isomers, and the phenomenon is known as the optical isomerism. The one which rotate to the clockwise dextrorotatory, तपाईले सुनिरहेको छ होला, dextro glucose त तपाई खानुहुन्छ, त्यस्तै dextrorotatory भन्छ organic compounds. Dextrorotatory किन भन्यो त्यो ग्लुकोजलाई, it will rotate the plane polarized light to clockwise direction, okay, and its isomer which rotates the plane polarized light to anti-clockwise direction, that is to the same extent, is known as the levorotatory. र अब कुनै पनि organic compounds त्यो optically active छ कि छैन भनेर हेर्नलाई यसरी त्यहाँ यदि we can see the practically with the help of a polarimeter, र यसरी हेर्ने जुन इन्स्ट्रुमेन्ट छ that is known as polarimeter, र त्यो polarimeter के हुन्छ भन्दाखेरि there will be a light source where there is a plane polarized light, र त्यहाँ एउटा क्याभिटी हुन्छ, ओके, त्यहाँ स्याम्पल होल्डर हुन्छ जहाँ तपाईले टेस्ट ट्युबमा अथवा कुनैमा ट्युब्सहरुमा होल्डर्समा त्यहाँ स्याम्पल राख्न सकिन्छ, and it is viewed from the opposite side, okay. So this is about the optical so this is the optical isomerism भन्दाखेरि, त्यसै optical isomerism लाई theoretically अब यदि practically छ भन्दाखेरि it's okay, हामी polarimeter मा राखेर हेर्छौं, तर theoretically हामीले how do we know अथवा which type of molecule will exhibit the optical isomerism भन्दाखेरि, यहाँ हेर्नुस् त, the condition required for the molecule to exhibit the optical isomerism that it should be dissymmetry, it should be dissymmetry भनेको के त, that is not symmetric, which is not symmetric. कस्तोलाई dissymmetry भन्छ, it does not have the plane of symmetry, that is unsymmetrical, okay. So that lack the plane of symmetry, or the molecule should not superimpose on its mirror image. र जुन molecule, जुन substance dissymmetry हुन्छ त्यसमा plane of symmetry हुँदैन, र जुन object अथवा जुन molecule dissymmetry हुन्छ त्यसको चाहिँ नि के छ, mirror image मा तपाईले superimpose गर्न खोज्दाखेरि हुँदैन, it does not superimpose on its mirror image, right. So हामीले condition required for the molecule to exhibit the geometrical isomerism पढेको थियो, त्यसमा के भन्यो, the condition required for the molecule to exhibit the geometrical isomerism के थियो, carbon carbon double bond and each double bonded carbon should be bonded to different atom or groups. तर यहाँ के छ, dissymmetry. अब dissymmetry भन्दाखेरि we can see, we can just give an example. Symmetrical, simply ball. Dissymmetry, palm. It doesn't have the plane of symmetry. It does not superimpose on its mirror image. यसको mirror image बनाउनुस् त, symmetrical भयो भने त्यसको माथि टक्क राख्दाखेरि mirror image मा राख्दाखेरि all the points coincide, okay. तर palm मा तपाई mirror image बनाउनु र त्यो mirror image मा तपाई यो जुन अहिले मैले जुन छ राइट ह्यान्ड ह्यान्ड को देखाइरहेको छ त्यो माथि राख्दाखेरि यो थम को ठाउँमा लास्ट फिंगर जान्छ, लास्ट फिंगर ठाउँमा थम आउँछ, it does not superimpose, okay. This is the case of object भन्दाखेरि हामी organic compounds मा कस्तोलाई symmetrical molecule भन्ने, कस्तो dissymmetric भन्ने भन्दाखेरि, here the example, the model is here, okay. See this carbon, organic compound, tetravalency, okay. Here the carbon is bonded with three similar atom of the group A, and A. Maybe the H, and A, so that will be methane, or Cl, that is the carbon tetrachloride. यिनीहरु यस्तो छ भन्दाखेरि, if in the carbon it is bonded with the same atom of the group छ भन्दाखेरि त्यो के हुन्छ त, त्यो symmetrical molecule हुन्छ र that will superimpose on its mirror image. So यस्तो molecule ले optical isomerism exhibit गर्छ त? Of course not. It does not. Okay. र जहाँ carbon मा if it is bonded with same atom or the group, this carbon is known as a chiral carbon. But in the organic compounds ma यसरी carbon is bonded to different atom or group. हेर्नुस् त, hydrogen, COH, OH, CH2OH, different atom or group. यहाँ पनि carbon bonded to different atom of group छ भन्दाखेरि this type of carbon is known as chiral carbon or asymmetric carbon. It is not symmetrical, it is asymmetric. अब यस्तो जुन molecule छ chiral carbon भएको, एउटै मात्र chiral carbon छ भन्दाखेरि अब molecule मा organic compound मा के हुन सक्छ भन्दाखेरि chiral carbon एक भन्दा बढी पनि हुन सक्छ. यसमा त एउटा मात्रै छ, यो chiral carbon होइन, यो पनि होइन. यो मात्र chiral carbon हो तर अरु एक्जाम्पलमा it may has another chiral carbons तर अहिले हामी जस्तै एउटा मात्र लिइरहेको छ एक्जाम भन्दाखेरि यो जुन कम्पाउन्ड छ त्यो कम्पाउन्डमा प्लेन अफ सिमेट्री छ त छैन र यसको मेरो इमेज बनाएर हेरौँ त तपाईको कपीमा मेरो इमेज बनाउनु त यहाँ OH मेरो राइट ह्यान्ड साइड छ भन्दाखेरि तपाईले बनाएको जुन मेरो इमेजमा लेफ्ट ह्यान्ड साइडमा हुन्छ है so it does not superimpose so this type of carbon is known as chiral carbon achiral chiral carbon is known as asymmetric carbon too तर के छ भन्दाखेरि chiral carbon भनेर यहाँ अर्गानिक कम्पाउन्ड्समा यहाँ आएर हामी इन्ट्रोड्युस गर्न आउँछौं chiral carbon भनेर र यसो हेर्दाखेरि के छ त युमी हामीले त के भन्यो मोलिक्युल शुड बी डिसिमेट्री भन्यो के छ भन्दाखेरि कन्डिसन डिसिमेट्री भन्यो कस्तो डिसिमेट्री हुन्छ भन्दाखेरि अफ कोर्स यदि एउटै मात्र chiral carbon छ भने त्यो जहिले पनि डिसिमेट्रिक हुन्छ so it will exhibit the optical isomerism यदि यति मात्र हामीले पढ्ने हो भन्दाखेरि you may have the wrong information that only एउटा chiral यदि chiral carbon is the condition required for the organic compound sorry to exhibit the optical isomerism so can we say the condition required for the molecule to exhibit the optical isomerism is chiral carbon just the chiral carbon no it is not यदि एउटा मात्र छ if it possesses only one it's okay all the compound that possess only one chiral carbon will always exhibit the optical activity but if it contain more than one then it may or it may not exhibit the optical isomerism यो हामी तलतिर जान्छौं example so the carbon that is bonded to 4 different atoms or group is known as the chiral carbon or the asymmetric carbon here and the molecule is known as disymmetric or chiral molecule हुन त डिसिमेट्रिक छ यो हुन्छ अप्टिकल तर chiral carbon मात्रै हुँदैमा पनि के छ भन्दाखेरि that compound may or may not be not exhibit the optical isomerism so let's go to the another example let's come to this example lactic acid okay yeah jun cha lactic acid bhandeपछि that is found in the milk sour milk ma okay your lactic acid your 2-hydroxypropanoic acid okay second ma OH group so 2-hydroxypropanoic acid is here COH group is a functional group propanoic acid अब यो lactic acid जुन छ 2-hydroxypropanoic acid मा के रहेछ त भन्दाखेरि it has chiral carbon yes only one chiral carbon र यो chiral carbon के छ it is bonded with hydrogen CH3 OH COH भन्दाखेरि it is bonded with different atom other group yeah so
हजुरको स्क्रिन मेरो मात्र नआयो अरूकोमा पनि नआएको
आइराछ यता त
आइराछ भर्खर आयो भयो भने
yes
sorry to interrupt ma'am
okay ठीक छ अब स्क्रिन त आउनै पर्यो नि तपाईको के टेक्निकल प्रब्लम भयो होला okay see so in the case of the lactic acid see this is your chiral carbon र यो chiral एउटै मात्रै छ एउटा मात्र chiral carbon हुँदाखेरि मैले के भने it is disymmetric it does not have the plane of symmetry and if you write the mirror image here in my right hand side is your hydrogen whereas in my left hand side यो जुन छ right hand side जुन यसमा छ hydrogen छ this hydrogen will be on the left hand side in the mirror image र अब यसलाई यो जुन lactic acid जुन हामीले यो dextrorotatory लेखिरहेको छ यसलाई माथि टक्क राख्न लाउँ त does it superimpose of course not यहाँ OH को ठाउँमा H बस्न आउँछ H को ठाउँमा OH हुन्छ it does not superimpose so this will exhibit the optical isomerism right so this is optically active compound यदि optically active compound यदि यो एउटा मात्र तपाईलाई थाहा छ भन्दाखेरि optically active यसरी does lactic acid exhibit optical isomerism explain भन्दाखेरि ए lactic acid को तपाईले यसरी देखाउन पर्यो okay structure formula देखाउन पर्यो र त्यसमा देखाउने बित्तिकै यहाँ के छ भन्दाखेरि यसो हेर्ने बित्तिकै के भयो it does not have the plane of symmetry as well as it possesses the chiral carbon so तपाईले के गर्नु पर्यो one is यो एउटा चाहिँ नि isomer हो भने अर्को isomer कस्तो स्ट्रक्चर हुन्छ भन्दाखेरि त्यसको mirror image another So if one is a dextro, another must be levo. That means this will rotate the plane polarized light to clockwise direction. So this is known as the dextro. And this, its mirror image, if this is dextro, this must be levo. And this will rotate the plane polarized light to anti-clockwise direction. र जहाँ optical isomerism भन्छ के छ, it will have the similar physical as well as the similar chemical properties with the melting point of 26 degrees Celsius, 26 degrees Celsius. Okay, have same molecular formula, same physical and the most similar chemical properties. तर हामीले geometrical isomerism मा हामीले पढ्दाखेरि के भन्यो, have the same molecular formula but they have different physical properties. है अस्ति जुन हामीले 2 butene 1 butene एउटा 4 डिग्री सेल्सियस एउटा 1 डिग्री सेल्सियस जुन त्यसको बोइलिङ पोइन्ट तिनीहरु हेरेको थियो भन्दाखेरि यहाँ आएर के छ भन्दाखेरि it has same physical properties like 26 degrees Celsius here. So lactic acid exhibit the optical isomerism. Does lactic acid exhibit optical isomerism? Yes, because it is dissymmetric molecule or it does not superimpose on its mirror image. One isomer of lactic acid rotate the plane of polarized light to clockwise direction known as dextrorotatory and the other isomer rotate the polarized light to anti-clockwise direction known as levorotatory. So what is optical isomerism? एउटा मात्र example जहाँ एउटा मात्र chiral carbon भएको यहाँ लियो हामी lactic acid मा. Or you may be asked the question, explain the isomerism that contain only one chiral carbon. Lactic acid पनि नाम दिँदैन, chiral carbon. त्यति बेला हुन त अरु पनि example लेख्न सक्छौं, तर good example is a lactic acid. Only one chiral carbon. Okay. भन्दाखेरि this is dextro levo भन्दाखेरि अब यस्तो जुन pair छ optical isomers that are the mirror image of one another. Is the pair is known as enantiomers, enantiomer. Okay, the optical isomer that are the mirror image of one another is known as enantiomer. So what is enantiomer? Give an example. What is enantiomer? Optical isomer that are the mirror image of one another is known as enantiomer. Example, you can give this simple lactic acid. So this enantiomer pair ma ke huncha ta? One will be dextro, another will be levo. They have same physical and the same chemical properties. Okay, भन्दाखेरि ए यो enantiomer भनेको खाली एउटा मात्र chiral carbon भएकोले मात्र हुन्छ कि के हो भन्दाखेरि of course not. It will exhibit by the compound that possess one or more than two chiral carbons जुन चाहिँ हामी पछि हेर्छौं. So what is enantiomer? भन्दाखेरि optical isomer चाहिँ त के छ भन्दाखेरि enantiomer हो नि जस्तै लाग्छ, तर यहाँ पछि अर्को पोइन्ट्सहरु आउँदैछ. So remember about the enantiomer. Okay, so this is enantiomer. So how to define enantiomer, or if you have to write about the enantiomer, the optical isomer that are the mirror image of one another is known as enantiomer. Enantiomer have same physical and the same chemical properties. One isomer of the enantiomer rotate the plane polarized light to clockwise direction and the another to anti-clockwise direction. So they are always in the enantiomer भन्ने बित्तिकै एउटा dextro र एउटा levo हुनै पर्छ है, र एउटा dextro levo हुनै पर्छ भन्दैमा यहाँ dextro levo within the bracket लेख्न पाइँदैन, जस्तै यसरी लेख्न पाइँदैन. यो लेख्ने बित्तिकै के भयो? That is racemic mixture. कसरी बन्यो? Equal molar of the enantiomer form the mixture which is optically inactive is known as racemic mixture. यदि enantiomer भन्दाखेरि यो जुन हामीले lactic acid छ त्यसलाई equal concentration equal molar मा यदि mix गर्यो भने के हुन्छ होला त? Of course त्यो mixture ले त्यो one of the dextro will try to rotate the plane polarized light to clockwise direction. त्यसमा equal molar भएकोले another will try to rotate into anti-clockwise direction. So the total rotation will be 0. So it will be optically inactive. हैन त? That is the equal molar भनिरहेछ. तर equal molar भएन भने यदि त्यो मिक्सचरमा dextrorotative बढी र levorotatory कम राखेको छ भने that mixture will be optical active. त्यसले चाहिँ के छ? यदि dextrorotative बढी राखेको छ भन्दाखेरि this domination हुन्छ र that mixture will rotate the plane polarized light to the clockwise direction. यदि levo बढी राखेको छ भन्दाखेरि it will rotate to anti-clockwise direction. तर if equal molar छ भन्दाखेरि of course it will be optically inactive, that is racemic mixture. अब यो racemic mixture को बारेमा अलि डिटेलमा हामी तल जान्छौँ. खाली racemic mixture भनेको के बुझ्यो है? So enantiomer are exhibited by the compound that possess one or more than one asymmetric carbon. एउटा मात्र asymmetric carbon छ भन्दाखेरि this is okay. अब एक भन्दा बढी छ भन्दाखेरि then we come to the another example है. So come to this example, that is tartaric acid. Getting me? Hello student. बुझिरहेछ हो?
Yes, ma'am.
Yes, ma'am.
Okay, so let's come to this tartaric acid. Okay, tartaric acid that is found in the grapes. Okay, that is a 2,3-dihydroxy butene dioic acid. Here's the COH. They here and the COH. So it is a dioic acid. 1 and 2 ma case hydroxy groups. It is 2 and 3 position ma hydroxy groups. So it is a 2,3-dihydroxy butene dioic acid. This is also tartaric acid. This is also tartaric acid, and this is also tartaric acid. तर के डिफरेन्स छ त? Arrangement of atom or group in space is different. यहाँ हेर्नुस् यसको ठाउँमा मेरो right hand side मा OH र H छ भने यहाँ H and OH छ तर यहाँ OH and OH छ. So we are talking about the stereoisomerism. Stereoisomerism भन्ने बित्तिकै के छ भन्दाखेरि molecule having the same molecular formula but they have different arrangement of atom or group in space. र त्यसमा पनि हामी के पढ्दै छौं? That is the stereoisomerism मा पनि हामी optical isomerism पढिरहेका छौं. Not the geometrical, है? Optical. र optical हुन पर्यो के हुन पर्यो? The molecule should be dissymmetry. त्यसैले जुन tartaric acid लाई यसरी हामीले different arrangement लेख्न सके पनि हामी के देख्छौं? This पहिला यो लेख्यो भन्दाखेरि पहिला यसमा हेरौं, यसमा plane of symmetry छ त? छैन. यसमा chiral carbon छ. This is also chiral carbon, this is also chiral carbon. र chiral carbon पनि कस्तो similar chiral carbon भन्छौं हामी यसलाई. हेरौं त. Similar किन भन्छौं? यो chiral carbon मा पनि एउटामा hydrogen is bonded, यसमा पनि hydrogen, यसमा OH, OH, COH, COH. Same groups हरु चाहिँ नि bonded भइरहेको छ. So this is your chiral, this is a chiral, and they are similar chiral carbon. If we arrange the tartaric acid in this way, then we can see that yes, this molecule will exhibit the optical isomerism because it does not have the plane of symmetry. यदि हामीले यसरी arrangement गरेको भए अब यसमा plane of symmetry. OH OH यता र HH यता अथवा मेरो left hand side मा OH OH राखेर HH यसमा राख्यो भने now it have a plane of symmetry. Though it has a chiral carbon, यसमा पनि chiral, त्यसमा पनि chiral carbon. दुईटा छ. तर arrangement यसरी छ कि it has a plane of symmetry, so this will not exhibit the optical isomerism. And this type of compound is known as the meso compound. यो tartaric acid भएको mesotartaric acid. Meso भन्नाले के बुझ्यो? जहाँ chiral carbon भएर पनि arrangement is in such a way that it has a plane of symmetry, so that one chiral carbon will try to rotate to clockwise direction, one chiral carbon will try to rotate into anti-clockwise direction, so the total rotation will be 0 and that will be meso compound. Whereas if we arrange the tartaric acid in this way, yeah, it does not have the plane of symmetry. So this is one tartaric acid, that is एउटा isomer, optical isomer को एउटा isomer हो भने अर्को isomer कस्तो त? Mirror image. हैन, यसको mirror image. So this 1 and 2 structure, they are optically active and they are a pair of enantiomer 1 and 2. Yes, they have same. One is dextro, one is levo, have the same melting and boiling point of 170 and 170. Okay, optical isomers and a pair of enantiomer. त्यही जुन tartaric acid मा के छ? यसरी पनि arrangement हुन सक्छ. Okay, छ भन्दाखेरि यसमा के रहेछ? Chiral carbon भएर पनि it is due to the plane of symmetry, it is optically inactive. And that is known as mesotartaric acid, and it has a melting point of 143 degrees Celsius भन्दाखेरि के बुझ्यो त भन्दाखेरि okay, tartaric acid मा पनि एउटा 70, 143 भन्दाखेरि the mesotartaric acid have different physical properties than its optical isomers. त्यसैले कुनै पनि organic compounds हरु कुनै पनि organic compounds हरु तपाईले physical properties याद गर्दाखेरि कुनैको चाहिँ molecular formula same melting and boiling point, तर same formula को they may have the different melting and boiling point. त्यति बेला के थाहा पाउनु पर्यो भन्दाखेरि सो तिनीहरु चाहिँ नि अप्टिकल आइसोमर्स होइन कि अथवा यहाँ अरु पोइन्ट पनि आउँदैछ त्यतिमा नजाऊ जस्ट अहिले चाहिँ के छ सो tartaric acid can exhibit in 3 different forms but 2 forms are optically active that is 1 that is the dextro 2 the levo because they are dissymmetrical and 3 form is optically inactive and it possesses the plane of symmetry so it is meso. The isomer of tartaric acid that is 1 and 2 are mirror image of one another so they are known as enantiomer whereas the mesotartaric acid possesses the chiral carbon double bond is here chiral carbons and chiral carbons but is optically inactive because it possesses the plane of symmetry that is known as the meso compound. Okay.
Ma'am.
Yes.
Mesotartaric acid लाई optical isomer भन्न पाइयो पाइएन ma'am?
पाएन. No, optically inactive.
Optically active मात्रै optical isomer भन्न पाइयो नि ma'am?
Yes. Optical isomers भनेको चाहिँ के छ भन्दाखेरि optically active हुन पर्यो. Plane polarized light लाई rotate हुन पर्यो. Dissymmetric हुन पर्यो. यो symmetrical भयो. तर meso board
कुन चाहिँ माइनस भनेर कसरी थाहा हुन्छ म्याम?
हजुर
यो कुन चाहिँ नि प्लस वाला हो कुन चाहिँ नि माइनस वाला हो भन्ने कसरी थाहा हुन्छ?
Oh yes, good question. Yes. अब यो चाहिँ मैले चाहिँ जुन लेखेको छ यो डेक्स्ट्रो एन्ड लेभो इट इज जहिले पनि यो डेक्स्ट्रो यो लेभो तर कुन चाहिँ थाहा पायो कसरी थाहा पाउने भन्दाखेरि देयर इज अ रुल दैट इज नोन एज सिक्वेन्स रुल जस्तै हामीले जेड र ई गर्यौं नि यो ज्योमेट्रिकल आइसोमर्समा जेड कसरी छुटाउने ई कसरी छुटाउने हैन दैट इज जुसामिन एन्ड इन्टेजिन भनेर ज्योमेट्रिकल आइसोमरिजम त्यस्तै गरेर यो अप्टिकल आइसोमरिजममा देयर इज अ रुल दैट इज नोन एज सिक्वेन्स रुल त्यो सिक्वेन्स रुल फलो गरेर then it is known as dextro and the levo. Right? The sequence rule चाहिँ नि हामी पढ्छौं लास्ट तिर पढ्छौं.
Okay ma'am.
है लास्ट तिर पढ्छौं यहाँ sequence rule छ तर लास्ट तिर मात्रै जम भनेर मैले यहाँ चाहिँ नि तपाईलाई चाहिँ पहिल्यै गरे भने तपाईहरु त्यसमै अलमली रहन्छ के सिक्वेन्स रुलमा अलमली रहन्छ त्यसो सिक्वेन्स रुल छ त्यो आधारमा चाहिँ नि which one is dextro which one is levo तर एक्चुअली सिक्वेन्स रुल भनेको आजकल यो जुन छ डेक्स्ट्रो लेभो भन्दाखेरि पनि त्यसलाई रेक्टस र सिनिस्टर्स भनेर छुट्याइन्छ ओके रेक्टस र सिनिस्टर रेक्टस मिन्स राइट ह्यान्ड साइड सिनिस्टर मिन्स लेफ्ट ह्यान्ड साइड है तर त्यही आधारमै हामी डेक्स्ट्रो लेभो भनेर छुटाउँछौं किन भन्दाखेरि यो अर्गानिक केमिस्ट्रीमा अहिले आएर कस्तो कम्प्लिकेसन भइरहेछ भन्दाखेरि कुनै अर्गानिक कम्पाउन्डमा देयर आर डिफरेन्ट धेरै एसिमेट्रिक कार्बन्सहरु हुन्छ काइरल कार्बन त्यसले गर्दाखेरि यदि एउटै यही केसमा यो ल्याक्टिक एसिड र टार्टरिक एसिडमा डेक्स्ट्रो लेभो छुटाउनलाई यो सिक्वेन्स रुलले सजिलो छ तर धेरै एसिमेट्रिक कार्बन छ भन्दाखेरि त्यसलाई अलि कम्प्लिकेसन हुने भएकोले आजकल जहाँ यो यो एसिमेट्रिक कार्बन्सहरु पनि छुटाउँदाखेरि के गरिन्छ भन्दाखेरि जस्तै यसलाई C1 C2 C3 C4 गर्दै जान्छ ओके यदि यो त एउटा दुईटा छ इट्स सिम्पल तर कुनै अर्गानिक कम्पाउन्डमा 1 2 3 4 5 6 पनि हुन सक्छ काइरल कार्बन त्यतिखेर सिक्वेन्सहरु रिप्लाई गाह्रो हुने भएकोले C1 C2 C3 C4 C1 ले कतातिर घुमाउँछ C2 ले कता घुमाउँछ भन्दै R1 R2 गरेर गरिन्छ तर तपाईहरु डिटेलमा पढ्नु छैन तपाईहरु एज एन इन्जिनियरिङ पोइन्ट अफ भ्यू तपाईको जुन एप्लिकेसन तिर मात्र जान्छौ हामी ओके त्यसैले त्यो सिक्वेन्स रु अप्लाई गरेर यसरी डेक्स्ट्रो लेभो भनेर हामी छुटाइन्छौं त्यो चाहिँ म लास्ट तिर जान्छु है त ओके सो tartaric acid so if you are asked to explain the isomerism in tartaric acid or explain the isomerism in 2,3 dihydroxybutane dioic acid or explain the isomerism in the compound that possess 2 similar chiral carbon भन्दाखेरि एउटै आन्सर tartaric acid भने पनि यही आन्सर 2,3 dihydroxybutane dioic acid भने पनि यही आन्सर आउँछ अथवा having 2 similar chiral carbon किनभने 2 dissimilar chiral carbon को example आउँदैछ पछाडी यो चाहिँ नि having the 2 similar chiral carbon है त so this is about the tartaric acid यदि तपाईले सोध्दा भन्दाखेरि explain the isomerism of tartaric acid अथवा this भन्यो भन्दा yes tartaric acid will exhibit the optical isomerism भन्यो and among the optical isomers, and it exists in 3 different forms. लेखिदियो यो स्ट्रक्चर लेख्यो र लेखेर मात्रै यति मात्र भनेर तपाई 1 2 गरेर इनाउन्समा 3 मेसो मात्र लेख्यो भन्दाखेरि तपाईको हाफ मार्क्स अलिकति एक्सप्लेन गरौँ है this 1 2 3 4 that is the figure 1 and the 2, they are dissymmetrical, and so they are the optical isomers of one another, and they are known as the enantiomer, whereas the structure 3 in this it is an symmetrical molecule. Tartaric acid is symmetrical due to the presence of the plane polarized light. It is arranged in such a way र एकचोटी symmetrical यसरी भइसकेपछि त्यसको फेरि mirror image बनाइराख्ने जरुरी छैन हैन कुनै कुनै किताबमा लामो गर्नलाई फेरि यसमा mirror image बनाइराखेको हुन्छ. I say it is not needed. तपाई यता OH right hand side मा लेख्नु अथवा left hand side मा OH लेखौं, it's same. Okay, र answer के point हुनु पर्यो? Optical isomer, enantiomer, meso. दुईटा चीज include गर्न पर्यो त्यो answer मा. भन्दाखेरि so what is meso? हामी यसरी हेर्दाखेरि यसलाई meso भन्दाखेरि अब त्यो meso so तपाईलाई अब यति हेरेपछि meso भनेपछि what is meso भन्दाखेरि तपाई के point generate गर्न सक्नुहुन्छ त? meso के point generate गर्न सक्नुहुन्छ हेरौं त. So organic compound which possess 2 or more chiral carbons but due to the presence of the plane of symmetry is optically inactive or will be optically inactive is known as meso compound. त्यसैले meso compound हुनलाई एउटै मात्रै chiral carbon भएर त्यो meso compound हुन्छ? Of course not. एउटै मात्रै chiral carbon छ भने त्यो कहिले पनि meso हुँदैन. Isn't it? Chiral carbon means it is bonded with different atom or group. तर त्यसलाई chiral carbon त्यो meso हुनलाई 2 अथवा 2 भन्दा बढी हुन पर्यो. त्यसले सो के हुन्छ? अझ त्यसलाई चाहिँ नि 2 अथवा it will have having the okay, is known as meso. In meso compound, one type of the asymmetric carbon tries to rotate the plane polarized light to right hand side, and the another asymmetric carbon tries to rotate the plane polarized light to left hand side. Therefore, the total rotation is 0, and this type of optical inactivity is said to be due to internal compensation. Yeah, sorry, optical inactivity मा पनि एउटा external compensation भनेर आउँछ, एउटा internal compensation. यो जुन meso compound मा optical inactivity किन त भन्दाखेरि internal compensation किन भन्दाखेरि यो जुन chiral carbon छ, your chiral carbon is similar to this, so this will try to rotate to the clockwise direction. This is similar to this, this will rotate to anti-clockwise direction. So within the molecule pani ke cha bhandakheri, so one type will try to rotate to clockwise, another to anti-clockwise direction to the same extent. So the optical inactivity in the meso compound is said to be due to internal compensation. That external compensation kun bela huncha ta bhandakheri यो दुईटाको mixture हामीले जुन racemic mixture भन्यौं नि हैन र यो जुन छ यदि if equal amount अथवा equal molar of the enantiomer जुन छ, so this will be optically inactive, and this optical inactivity is said to be due to external compensation. किन त? किन भन्दाखेरि whole molecule will try to rotate to clockwise direction, whole molecule will try to rotate into anti-clockwise direction. एउटै molecule भित्र नि भएको होइन नि त. So this is said to be optical inactivity is said to be due to external compensation. That is the racemic mixture. But meso भन्ने बित्तिकै that is internal compensation. The racemic mixture, meso, both are optically inactive. Yes, the meso form possess different physical properties than its dextro and its levo isomer. Meso. So what is meso compound? You can give the example with this tartaric acid. Right there. Now we can give this another example too, that is 3-bromo-2-butanol. 3-bromo-2-butanol हेरौं त structure सबै यो हो कि होइन? Are these all 3-bromo-2-butanol? One, two, three. 3-bromo-2-butanol. 1, 2, 3. 1, 2, 3. 1, 2, 3. हुन त हो नि अब तपाईले so explain isomerism in 3-bromo-2-butanol भन्दाखेरि तपाई 3-bromo-2-butanol को स्ट्रक्चर राम्ररी लेख्नु पर्यो. ब्युटानोल भनेपछि 4वटा कार्बनको चेन बनाउने 1 2 3 4 ब्युटेन ब्युटानोल के भनेछ 3-bromo 1 2 3 ब्रोमो तपाईले पहिला यो लेखे पनि भयो पहिला यो लेखे पनि भयो जुन लेखे पनि भयो तर म यतैतिर जाम ओके मैले यता लेफ्ट ह्यान्ड साइडमा ब्रोमो लेखे भन्दाखेरि 2-butanolमा मैले त्यहाँ OH लेखेछ भन्दाखेरि यहाँ हेरौँ त does this molecule exhibit the optical isomerism or not भन्दाखेरि of course yes किन त it does not possess the plane of symmetry छ र छैन plane of symmetry छैन यहाँ कतिवटा chiral carbon छ again the 2 1 2 sorry है दुईटा chiral carbon छ यो र यो तर यो दुईटा कार्बन कार्बनलाई अघि हामीले टार्टिक एसिड जस्तै सिमिलर chiral carbon भन्न मिल्छ can we see the similar chiral carbon or not as in the tartaric acid हामीले टार्टिक एसिडमा यो दुईटालाई सिमिलर chiral carbon भनेको थियौं सिमिलर chiral carbon भनेको थियो भन्दा यो यसलाई चाहिँ नि हामी सरी यसलाई पनि हामीले सिमिलर chiral carbon भन्न मिल्छ कि मिल्दैन कम अन
मिल्छ होला म्याम अनि मिल्दैन म्याम
यस मिल्दैन किन मिल्दैन त केले डिफरेन्स भइरहेको छ हेरौँ त
4वटा एटम्स फरक फरक छन् तलमाथि
यस गुड let me download your attendance 47 of you are there okay so yes this is chiral carbon दुईटै छ तर dissimilar chiral carbon है त किन भन्दाखेरि यो मिल्छ this and this मिल्छ यसमा OH छ भने यहाँ Br छ तर it does not have the plane of symmetry so this will exhibit the optical isomer यदि यो optical isomer हो भने त्यसको अर्को isomer structure के हुन्छ mirror image र यो यसमा plane of symmetry नभएपछि यसलाई यहाँ राख्न ल्याए भन्दा के छ does it coincide of course not है H को ठाउँमा OH बस्न आउँछ Br को ठाउँमा H OH ठाउँमा H here so it does not coincide so this is a pair of enantiomer yes this A and B a pair of enantiomer of 3-bromo-2-butanol तर मैले यसरी स्ट्रक्चर लेखेको छ भने 3-bromo-2-butanol 1 2 3 3-bromo-2-butanol एकै साइडमा लेखे भन्दाखेरि यो पनि chiral carbon हो यो पनि chiral carbon यो पनि dissimilar these two are dissimilar किनभने OH Br 2 3 3-bromo-2-butanol नभइकन यो स्ट्रक्चरमा के छ भन्दाखेरि यदि yes 2 and 3 hydroxybutane yes 2 3 dihydroxybutane भएको भए यसमा again it will have the plane of symmetry त्यो चाहिँ नि मेसो हुन्थ्यो अथवा 2 and 3 dibromobutane भएको भए पनि यहाँ के हुन्थ्यो यो plane of symmetry हुन्थ्यो र मेसो हुन्थ्यो तर यहाँ के छ 3-bromo-2-butanol यो दुईटा डिफरेन्ट भएकोले now it does not have the plane of symmetry र so this will exhibit the optical isomer र त्यसको अर्को isomer को structure will be its mirror image भन्दाखेरि यहाँ चाहिँ हामीले चारवटा स्ट्रक्चर लेख्नु पायो 3-bromo-2-butanol मा a pair of enantiomer another pair of enantiomer भन्दाखेरि यहाँ 2 pairs of enantiomer बन्यो तर हामीले tartaric acid मा only 1 pair of enantiomer मात्र बनाउन सकेको छ है यहाँ tartaric acid मा पनि दुईटा chiral carbon छ है तर अलि डिफरेन्ट छ 2 similar 2 dissimilar है so we can write the isomers कतिवटा लेख्न सक्यो त हामीले चारवटा जसमा 2 pairs of enantiomer okay A and B are optical isomers and are mirror image of one another so enantiomer plus and this positive and negative these pairs have similar physical and chemical properties याद गर्नुस् है यो this pair will have similar physical and chemical properties C and D are optical isomers that are the mirror image of one another so it is an enantiomer this is also enantiomer tara these pair have same physical and chemical properties but different from A and B. The point to note here, okay, the point to note here is ke bhanyo, this and this enantiomer, it's okay, same physical and chemical properties. This and this enantiomer, okay, same physical and chemical properties. But it is said that the chemical and physical properties of C and D is different to A and B, or the physical properties and chemical properties of A and B is different from C and D. Now, with this, यसले गर्दाखेरि now the another term आउँदैछ, that is distereomers. त्यसैले यहाँ के छ, so if we distereomers भनेको के त भन्दाखेरि यहाँ हेर्नुस् त, पहिला compare गरौँ, compare A with C. A and C छ, यो optical isomer हो, यो पनि optical isomer हो, तर A र C compare गर्दाखेरि same molecular formula, तर तिनीहरु mirror image हो त होइन. त्यसै गरेर A and D optical isomer, तर A र D mirror image हो त? No, but they are not the mirror image. B and C, B र C दुवै optical isomers हो, are optical isomer, but they are not the mirror image of one another. त्यसै गरी B and D, they are the optical isomer, but they are not the mirror image of one another. भन्दाखेरि यस्तो pair optical isomers मा पनि के रहेछ, having the same molecular formula, but they are not the mirror image of one another छ भने, that pair is known as distereomers or distereomers. Distereoisomers or distereomers. है, अब यहाँ आइसकेपछि another point is to note. So what is distereomers then? So distereomers भन्ने बित्तिकै हुन त यहाँ अलिकति कन्ट्रोभर्सी आउँछ, हामीले के छ, no, yes, यो के छ, optical isomers that are not the mirror image of one another. If they are the mirror image of one another, enantiomer. If they are not the mirror image, then distereomers. Enantiomer हुँदाखेरि जहिले पनि पेयरमा के एउटा डेक्स्ट्रो र यो लेभो हुन्छ भन्दाखेरि डाइस्टरर्समा के हुन्छ, one pair may be A र C compare गर्दाखेरि डेक्स्ट्रो एन्ड डेक्स्ट्रो पनि हुन सक्छ, अथवा चाहिँ नि के भयो डेक्स्ट्रो एन्ड लेभो पनि हुन सक्छ, ओके, अथवा लेभो एन्ड डेक्स्ट्रो पनि हुन सक्छ, अथवा लेभो एन्ड लेभो पनि हुन सक्छ है. So with these points, so now if you are asked what is distereomers, so how to define, distereomers के हो त है, यदि बुझ्यो भन्दाखेरि you can generate the points. अब distereomers मा के हुन सक्छ, so optical isomers that are not the mirror image of one another is known as distereomers. Sorry. Okay, so optical isomers that are not the mirror image of one another is known as distereomers. Distereomers possess different physical and chemical properties. Herom ta? Hey, enantiomers have the same physical and same chemical properties. The distereomers have different physical and chemical properties. Distereomers are always in dextro र लेभो पनि हुन सक्छ, डेक्स्ट्रो पनि हुन सक्छ, लेभो पनि हुन सक्छ, तर enantiomer always dextro and levo. र यसमा अब equal molar of distereomers may or may not form the racemic mixture. तर equal molar of the enantiomers मा के थियो, always form the racemic mixture. तर यसमा यदि यस्तो छ भन्दाखेरि racemic mixture हुन्छ हैन, तर यस्तो भयो भने त racemic mixture बनेन. Okay, it is exhibited by the optical isomer that possess two or more dissimilar chiral carbon. यदि एउटै मात्रै isometric carbon छ भने त्यो distereomers exhibit गर्छ त? Of course not. So good example is your 3-bromo-2-butanol and 2,3-dichloropentane. यो 2,3-dichloropentane हामी next time गर्छौं. तर यहाँ point to note तपाईले कतिवटा point note गरे भन्दाखेरि जुन optical isomers मा बुझ्ने point भनेको के रहेछ, optical isomers भन्ने बित्तिकै हामीले related to the plane polarized light, that is okay. तर हामी theoretical point मा जाँदाखेरि कस्तो हुन पर्छ त molecule कस्तो हुन पर्छ त dissymmetrical त्यसमा we came to the example कस्तो molecule हुन्छ त्यसैमा chiral carbon भनेको के हो achiral carbon अथवा chiral carbon achiral carbon भनेको कस्तो भन्छ कसरी plane of symmetry हुन्छ कसरी plane of symmetry हुँदैन त्यसमा good example हामीले lactic acid लियो okay that has only one chiral carbon pair of enantiomer अब यसले diastereomers exhibit गर्छ त never यदि एउटै मात्र chiral carbon छ भने that molecule will not exhibit the diastereomers है so this is your point to note है र lactic acid so explain the isomerism that भन्नुस्
lactic acid मा OH को ठाउँमा H मात्र राख्दिएपछि म्याम त्यसको ऑप्टिकल आइसोमर बन्ने भयो कि बन्ने भएन म्याम
बन्दैन it should be different atom of the group हुनु पर्यो नि त
asymmetrical त भयो त म्याम फेरि asymmetrical त भयो नि HH राखे पनि
asymmetrical त भयो it should have the chiral carbon पनि हुनु पर्यो नि त कहाँ symmetrical हुन्छ र यहाँ COH छ यहाँ CH3 छ कसरी symmetrical हुन्छ हुँदैन नि है हुँदैन नि या COH CH3
मिरर इमेज त बन्ने भयो जस्तो पनि
कसरी सिमेट्रिकल हुन्छ
सिमेट्रिकल भयो त का हो एसिमेट्रिकल भएपछि हो नि त म्याम अप्टिकल आइसोमर हो नि त
त्यही त है now so this is with the lactic acid को एउटा मात्र भएको जुन छ chiral carbon को example भयो next is your हामीले so त्यसैमा enantiomer भनेको के हो okay point to note त्यसै गरेर हामीले tartaric acid लियौं tartaric acid जाँदाखेरि हामी मेसोतिर आयौं हैन one pair of enantiomer र मेसो भनेको के हो त हामीले यहाँ यसरी अलिकति point generate गर्यौं त्यसै गरेर diastereomers भनेको के हो त यदि यो बुझेको छ भन्दाखेरि हामीले diastereomers लाई यसरी point generate गर्न सक्छौं र तपाईलाई जाँचमा सोध्दाखेरि you may ask write the difference between the enantiomer and diastereomers तपाईको कपीमा एउटा लाइन राखेर लाइन ड्रा गरेर enantiomer र diastereomers लाई साइड साइडमा राखेर पढ्नु होला सजिलो पनि हुन्छ त्यसो कहिले सोधि पनि राख्छ write the difference between enantiomer and diastereomers है difference भन्दा बित्तिकै optical isomers that are the mirror image of one another diastereomers optical isomers that are the mirror image of one another enantiomer diastereomer possess different physical and chemical properties enantiomer possess same physical and chemical properties diastereomers are always in this the enantiomers are always dextro and levo equal molar of this may or may possess the restaurant mixture the equal molar of the enantiomer always form the restaurant mixture it is exhibited by the optical that possess two or more dissimilar the enantiomer it is exhibited by the compound that possess one or more than one hey example is here example यसैमा हामी this अथवा lactic गरेर enantiomer त्यो देखाउन सक्छ है तर कपीमा तपाईको रफ कपीमा लेखिहाल्नुस् डिफरेन्स बिट्विन enantiomer र diastereomers किनभने पोइन्ट सँगसँगै लेख्यो भन्दा त्यसलाई सजिलो हुन्छ now for this yes we can give 2-3 dichloropentene also अब यसलाई अर्को जान्दाखेरि फेरि अलिकति racemic mixture इनरको रेजोल्युसन नेक्स्ट टाइम मात्र गरौँ न अनि सिद्धिन्छ है त Next day, let's do you बुधबारे गरौँ न first period. Hello, student. Are you okay with that? बुधबारको यो first period जुन तपाईहरुको खाली अस्ति पनि मैले लिए. Hello, CR. Very CR. खोइ त CR कहाँ गयो? Achal, Ashwin, Abhishek. आज CR कहाँ गयो? तपाईको CR खोइ?
कनेक्सन गयो होला म्याम कनेक्सन गयो होला
ओके VCR छ त यहाँ? असीम
अक्षिता यस म्याम
ओके कहाँ गयो ओके भिसिआरले एउटा के काम गरौँ भन्दाखेरि लेट्स डु वान एउटा चाहिँ नि बुधबार चाहिँ नि हामी त्यही 10:15 to 11:05 मा क्लास लियौँ 11 सम्म है एलसिआर त्यो गरिदिनु सो द्याट हामी चाहिँ नि अनि बुधबार चाहिँ नि हामी के गर्न सक्छौँ भन्दाखेरि यो अप्टिकल आइसोमर्स हामी सिद्ध्याउँछौँ के
ओके म्याम
है है
यही
So,
हैन
as a-
हाम्रो लास्ट च्याप्टर
हजुर
लास्ट च्याप्टर यही अप्टिकल आइसोमेरिजम हैन र हाम्रो
त्यही त अप्टिक होइन अनि फेरि अरू पढ्नु पर्छ नि त
ए हैन भ्याइन
अप्टिकल आइसोमर र ज्योमेट्रिकल हो हैन देन विल गो टु द अनदर टपिक भनेर कसैले अलि अप्ठ्यारो छ भने यस के अरे सिआर अफ भिसिआर मलाई खबर गर्नु होला हैन यदि बुधबार तपाईलाई अप्ठ्यारो छ भने नल्याउँ कन्टिन्यू गरौँ तर मेरो क्लास अरूमा सबै सिद्धिसकेकोले त्यसैले चाहिँ नि बुधबारै लिएर सक्यौँ कि भन्ने मेरो विचार छ यदि मिल्यो भने बुधबार लियौँ अप्टिकल आइसोमर सिद्धिन्छ देन विल गो टु मेबी अर्को टपिकमा जान्छु किन अरू टपिकमा अब के बाँकी छ भन्दाखेरि के अरे एक्सप्लोसिभ इज देयर एज वेल एज पोलिमर्सलाई दुईटा लेक्चर चाहिएला एक्सप्लोसिभलाई एउटा लेक्चर चाहिन्छ देन वी विल गो टु पेन्ट्स एन्ड दि लुब्रिकेन्ट्स है देन वी विल अनाउन्स द असेसमेन्ट टु अब नेक्स्ट विकमा हामी असेसमेन्ट पनि अनाउन्स गर्छौँ होला असेसमेन्टसम्म हामी यति राख्छौँ द्याट इज रिएक्सन मेकानिजम र यो के अरे स्टिरियोकेमिस्ट अप्टिकल यो आइसोमरिजम ओके सो क्यान वी लिभ तपाईँको अर्को के क्लास होला सो लेट्स लिभ द क्लास थ्याङ्क यू